Welcome to the second section of Chapter 2. In the first section, we looked at general distributions, we talked about percentiles, we talked about z-scores. Today's notes are all about normal distributions. So we haven't talked about this term yet. You might have heard it in other classes, but a normal distribution is a very specific bell shape. It comes up a lot of times in real life. Height, weight, test scores all tend to be normally distributed, tend to have the same shape. So whole lot of things that we're going to learn today. We're going to draw some pictures. We're going to do a lot on the calculator. So if you don't have your graphing calculator out, make sure that you take it out, please. Let's get started. Okay, please find this page in the notes. Start out with a little bit of vocab. What is a normal density curve? So a normal curve is a very specific bell shape. And you would be given a mean and a standard deviation, or you might have to identify them. So that's the next question. How do you identify them? Okay, so if we draw in this very specific bell curve, the mean is going to be in the middle. And then to estimate the standard deviation, there's kind of two ways you're going to do that. The first way is you're going to look for where the graph changes from concave up or concave down, really, to concave up. So this point of inflection. This is generally going to be one standard deviation. The second way that you're going to estimate standard deviation, we'll see in a few examples. So this is what we're looking at today, is these specific normal distributions. So let's keep going. According to the CDC, the heights of 12-year-old males are approximately normally distributed with a mean of 149 centimeters and a standard deviation of 9. Sketch this distribution, labeling the mean and the points 1, 2, and 3 standard deviations from the mean. Okay, so what we're going to do, we're going to draw in this normal curve. First thing that you are going to do is you are going to label with symbols only. So the mean goes in the middle. We have 1 standard deviation above, 2 standard deviations above, and 3 above. Then we have 1 below, 2 below, and 3 below. Every single normal problem, you have to have those labels. So every single problem that you do, you will draw this figure approximately 500 times. And I'm not exaggerating, it's going to be 500 times. You need to have all of those labels, then the labels from the problem. So the mean is 149. So 1 standard deviation above then is 158, and then 167. I'm just adding 9, and then 176. So 1 below then would be 140, and 131, and 122. So this is our perfectly labeled normal curve. Okay, we're going to keep moving. Because I'm doing this in a video and not teaching you in class, we're going to skip this example, which was just going to lead us to what is called the 68, 95, and 99.7 rule. First thing that you need to know is this rule only applies to approximately normal distributions. That's really, really important. Has to be an approximately normal distribution, and that would be stated in the problem. Okay, so what this rule tells us is that about 68% of the data is going to be within 1 standard deviation of the mean. Likewise, about 95% will be within 2 standard deviations, and about 99.7% would be within 3. Okay, I think it's easiest to use this if we just do an example. So we are going to do these 2 examples together. Using the example above, what percentage of 12-year-old boys will be over 158 centimeters? And what percentage will be between 131 and 140? Okay, so earlier we were told that this is an approximately normal distribution. If you are told it's approximately normal, first thing that you're going to do is you're going to draw a figure. And then you know that you can use the 68, the 95, and the 99.7 rule. So the first thing that I'm going to do is I'm going to draw the figure again. because we're going to need to use it. So on Notability, you can probably just copy yours. I'm going to have to actually draw mine again, though. So mean, standard deviation, 2, 3, and then 1 below, 2 below, 3 below. Okay, so then the mean was 149. So then we have 158, 167, 176, and then 140, 131, 122. Okay, so using that rule, the 68, 95, 99.7, within one standard deviation is 68% of the data. So that tells us between 140 centimeters and 158 centimeters, about 68% of 12-year-old boys will fall here. The next thing that we know is within 2 standard deviations is about 95% of 12-year-old boys, and within 3% or within 3 standard deviations is about 99.7. Okay, so this is the way you're kind of thinking. So then when we go to this first example, what percentage of boys will be over 158 centimeters tall? First thing that you're going to do is figure out what area you're talking about on the figure. So 158, keeping in mind this isn't a perfect figure, is here. This is what I'm being asked for. This is what I'm being asked for. Okay, so I know within one standard deviation, like we already said, is 68%. So if I take 100% and I subtract 68%, that means that 32% is outside of that area. So 32% is going to be here and here. Because of the symmetry of the figure, so 32% here and here, because of the symmetry of the figure, I can say that this red tail then is 16%. Okay, so percentage of 12-year-old boys that are over 158 centimeters, we would say about 16%. So then if we are looking at this second example, what percentage of 12-year-old boys will be between 131 and 140? We are looking now for this piece right here. Okay, so we might have to get a little bit more creative. There are a ton of different ways that you can do this. Okay, a ton of different ways that you can do this problem. I'm going to show you one possible way. So between this 131 and this 167, so in this area right here, we have 95% of the data. So what I need then is only this part, which means I don't care about this part and I don't care about this part. Okay, so what I'm going to do is if I take that 95% and I subtract 68%, that gives me 27%. That 27% is this tail and this tail together. So you're going to have to visualize that. You're taking the 95%, so you're taking all of this, but subtracting the 68, leaving just these parts on the side. Because we want only one side, you're going to divide that by 2. So about 13.5%. And note here, I'm giving my answer as a percent because I'm asked for a percent. Okay, so that is the 68, 95, 99.7 rule. This can be hard for some people to wrap their minds around because it's very visual. You'll just do some more practice. It's fine. So if you can't really see that, that's okay. One thing for you to note is that you can use the 68, 95, 99.7 rule to estimate standard deviation. So let's say we go back to this example that we skipped. If we wanted to estimate the standard deviation here, what we would do is look for where we thought 68% of the data in the middle fell. So out of 50 students, I would have to look for the middle 34. And that then would be the mean plus the standard deviation on one side and subtract the standard deviation on the other. I know I went through that quick, so if you need to do a little rewind and listen to that last minute again, please do so before moving on. Okay, next example. Suppose that a distribution of test scores is approximately normal, and the middle 95% of scores are between 72 and 84. What are the mean and standard deviation? Okay, when you're reading this, there's a few things that should jump out to you. First thing, you should see approximately normal. That's really important. And then we see middle 95%. So approximately normal, we can use the 68, 95, 99.7 rule. And then when we see middle 95%, we're talking within 2 standard deviations. So what that means is we have the mean, we added a standard deviation and added another one, and that got us to 84. Then when we took the mean and we subtracted a standard deviation and we subtracted another standard deviation, we got to 72. So on a figure, we're looking at the mean, add standard deviation and add to get to 84, subtract and subtract to get to 72. So hopefully either way that you see this happening, we're talking about 4 standard deviations in this range. So from 72 to 84, 12 points happened. If those are 4 standard deviations, then that tells us our standard deviation is 3. We also have to find the mean. So if we added 3 here and we added 3 here, the mean then had to be 78. And that should make sense on the figure. If we look at this figure, 78, 81, 84, 78, 75, 72. Okay, last question of this type before we move on. Can you calculate the percentage of scores that are above 80? So if we look at this pretty poor figure that I drew above 80 is like here, this area. Now, the problem is that's not 1, 2, 3 standard deviations. It's not a whole number. Not a whole number. It's like 0.67 standard deviations. It's not a full standard deviation above the mean. So can we calculate this currently? No. No. It's less than 1 standard deviation. So 68, 95, 99.7 rule does not apply. If that's the case, we have a normal distribution and we can't use 68, 95, 99.7. What you're going to do is you are going to look to the calculator. So at this point, very important that you take your calculator out. Okay, so what we're going to move into next is in general calculating any type of normal distribution calculation in your calculator. So first we're just going to look at what's called the standard normal, and then we're going to look at any normal distribution. Okay, so first thing to know, when we say standard normal, here's what you need to know. First thing you need to know is we're talking about z-scores. So you're going to see z. Next thing you need to know, like we talked about before, mean of the z-scores is always going to be 0 and standard deviation is always going to be 1. Okay, so if I draw myself a nice general normal curve, starting with labels of mean, standard deviation, 2 standard deviations, and 3. -1, -2, and -3. Okay, because these are z-scores, right? In each of these problems you're looking at, you have a z. The mean is 0, and the standard deviation is 1. Okay, so this first problem is asking us for the probability that z is less than -3.16. So here's our -3, so -3.16 is about here. So this is what we're looking for, a very, very small probability. The second one is asking us for the probability of being between -0.5 and 1.21. So -0.5, again, we're looking at these blue numbers, is about here. And 1.21 is about here. So we're looking for this probability, that area. And then the last one, z is greater than 2.5, so that's about here. And we're looking for bigger than that. Okay, so these are the 3 things that we're going to look for. We're going to do all of them in the calculator at the exact same time. One thing that I want to point out to you, though, before we go to the calculator, you might have noticed on the second one, we have less than and we have less than or equal to. In terms of area, there's no difference. In terms of area, there is no difference. Okay, so let's take a look at the calculator. Okay, so on the calculator, what we want to do is figure out where the normal distribution is housed. So there's actually, it's not in the stat menu, but there's a button close to the stat that says vars. And above vars, you see distribution. So if you hit second distribution, you see some options here. And you see the first three have norm in them. There's normal PDF, normal CDF, and then that inverse norm is also for a normal distribution. Normal PDF you will never use. Normal CDF, on the other hand, means cumulative. And so what that does is it looks for an area. So it's going to look for an area on a normal curve. So if you hit normal CDF, now my calculator tells you specifically what it's looking for. Yours might not, but it still needs the same 4 pieces of information. It needs the lower bound, the upper bound, and the mean and the standard deviation. So our first one, z, is less than negative 3.16. There is no lower bound, right? That distribution just keeps going forever. That number line keeps going forever. So what you're going to do is you're just going to put in a really big negative number. So I just have a -1 with a bunch of zeros. Then our area is going until negative 3.16. Because these are z-scores, your mean is going to be 0 and your standard deviation is 1. So that's our answer then. The probability or the likelihood of choosing a z-score less than negative 3.16 is really, really small, very close to 0. So now, same idea with that problem in the middle. You're going to go back to second distribution to choose normal CDF. This time, our shading starts at negative 0.5, and it goes until 1.21. Z-score again, so the mean is 0 and the standard deviation is 1. So there we go, 0.588 about is the area between negative 0.5 and 1.21. So then our last one, part C, the probability that z is greater than 2.5. This time our shading starts at 2.5 and it keeps going. It keeps going forever to a really big number. Now, what I could do again is put a big positive number, 1 with a bunch of zeros behind it. Or an efficient way to do that is 1 times 10 to the 99th. The way I got that e, so that e just means times 10 to the 99th, is I went second and comma. Second comma, so this is 1 times 10 to the 99th. If you don't like that, just put in a really big number. And then again, our 0 and 1. And that is our answer. Okay, that was a lot on the calculator. If you need to rewind and go back through those 2 minutes, please do so. There will be some more calculator work coming up where we can practice this some more. Okay, so recording our answers real quick. For the first one, we got 0.0008. About. For the second one, we got about 0.58. And for the last one, we got about 0.0062. So now what we have to be able to do is work in the opposite direction. So this time, we've been given an area. We need to find the z-score. So we've been given an area, we need to find the z-score. So again, let's go back to the calculator. Because we're still working with a normal distribution, you're going to go to the same spot, that second distribution. So you're going to hit second distribution. This time, though, we're working backwards. So we're no longer going to choose normal CDF. This time, we're going the reverse direction, so we're going to choose inverse norm. Now here is where our calculators look a little bit different. Mine is asking for area, mean, standard deviation. Some of your calculators, the ones that have a newer piece, ask for the tail also. And we'll get to that part in a minute. So smallest 2% means the area is 0.02. Again, we're talking z-scores, so the mean is 0 and the standard deviation is 1. If you are asked for tail, or something along those lines, smallest would be the left tail, so you're going to choose left. And this is the z-score we get, about negative 2.05. So let's draw a picture and make sure we understand what that negative 2.05 means. Okay, so what we're talking about here is if we have a normal distribution and we have a mean of 0 and a standard deviation of 1, negative 2.05 -2.05 is about here, so that's a z-score, and the area smaller than that is 2%. Okay, so our answer is -2.05. And you might want to write down we used inverse norm. Okay, middle 95% is going to look a little bit different depending on what calculator you have. So middle 95%. This one you actually should already maybe know the answer to. So we know that about 95% of the data falls within 2 standard deviations of the mean. So our z-scores are going to be about 2 and -2. But let's see how to do this on the calculator. If you have the newer calculator with the tails, you would tell the calculator, okay, my area is 0.95, and then the calculator will either say middle or center. I can't remember. On my calculator, though, my calculator will not do the middle. It will only do a lower probability. So I don't have a way of putting in 0.95. I need to correlate that with this lower tail. Okay, so if 95% of the data falls within those blue lines, 5% falls outside in this tail and this one, which means that tail on the left is 0.025. So now let's look back at the calculator. Okay, so on the calculator, again, I'm going to do second distribution. Because I have an area, I'll go to inverse norm. And I have 0.025 because these are z-scores, mean of 0, standard deviation of 1. So like we said, we knew we should get around -2 and +2, or around 2 standard deviations, and our answer is -1.96. So let's look back at our figure and see if that makes sense. Would a -1.96 make sense where I drew it? Well, yes, it would. It should be below the mean. But now we also need this area on the, or this value on the right, right? There's 2 of them that contain the middle 95%. Well, because of the symmetry of the curve, that's going to be a positive 1.96. So we get -1.96 and positive 1.96. So that is the inverse norm function. For the interest of time, we're going to skip this third one. Okay, so where this is going to take us to now, well, actually, before we get to that, maybe you have been wondering why there was this big dot piece of money in the right corner. That is actually some money from Germany, and you can't really tell unless you scroll in, but they actually have a normal distribution on their dollar. So, pretty cool, right? I know, I'm a nerd. I think it's cool. Anyway, now we know how to use the calculator for standard normal distributions when we have z-scores. But the question is, what do we do if we're not talking about z-scores? We're talking about a different normal distribution where maybe the mean is not 0 and the standard deviation is not 1. How do we do that on the calculator? That's what we're going to look at next. Okay, so now let's say that we are looking at women's heights. And I'm going to tell you that women's heights are normally distributed with a mean of 65 and a standard deviation of 2.5. And the way to write this is like that. Okay, so let's say maybe we want to know what is the proportion of women that are less than 5 feet or less than 60 inches. Okay, first thing that we are going to do is two things. One, we're going to write out, we know that women's heights are normally distributed with a mean of 65.5 and a standard deviation of 2.5. Even if that is given to you in the problem, you are expected to rewrite it. There are 2 ways to go about this. One is a long way where we convert everything to z-scores, or we can use the calculator. The only way that you can use the calculator, though, is if you have written this out. So if you don't write this out, you have to use z-scores. If you do write out that one line, you don't have to use z-scores. So because we've written out that line, we're not going to use z-scores. But again, I cannot stress enough the importance of that one line. Okay, so besides writing that out, we're going to draw our figure. So I told you we're always going to start with mean, standard deviation, 2, 3 standard deviations. We'll go 1 below, 2 below, 3 below. Now, we know that the mean from the problem is 65.5, and we're going to add 2 standard deviations up, or we're going to add standard deviations up and below. So that's that 2.5. So if we add 2.5, we're going to get 68, and then 70.5, and then 73. If we go down, we get 63, 60.5, and 58. So that is the first thing that you are always going to do, is you're going to put this in symbols, and then you're going to draw yourself a figure. So now, finally, we can go to the question that we're being asked. So what percentage of women are less than 60 inches? So we're going to put that on our figure, 60, and we are going to go less than that. And then you can go to the figure, or then you can go to the calculator, rather. Because we are looking for an area, you're going to do normal CDF. Lower bound is just a really big number, so I'm going to do -1 times 10 to the 99th. Stopping at 60, mean of 65.5, and a standard deviation of 2.5. So let's go to the calculator. Okay, so we're going to go back to that second distribution. Choose a normal CDF. Our lower bound is that really big negative number, or a number that's really negative. So -1 times 10 to the 99th. To get that E, that times 10, remember you're going to do second comma. You don't have to do that. If you don't want that, just type in a -1 and a whole bunch of zeros behind it. And then we're going up to 60 inches, or to 5 feet. And then our mean is 65.5, and our standard deviation is 2.5. And there we go. We get an answer of about 0.014. So answer of about 0.014. So right now you should be doing a mental check and asking, does this look like an area of about 0.014? Keeping in mind the entire area is 1. Well, yeah, it looks really small. Okay, so that is the probability of being less than 60 inches. Or another way to say that is the proportion of women less than 60 inches. Okay, let's do one more. Let's say next we want to know the proportion of women that are between, or the probability of being between 5 and 6 feet. So how many women are between 5 and 6 feet? Well, 5 feet we know already is that 60 inches. And then 6 feet would be 6 times 12 is our 72 inches. So because I'm lazy, I'm just going to reuse the figure that we already have. So first thing that we said is we need to define how our variable is distributed, but we already did that in yellow. We know that women's heights are normal with the given mean and standard deviation. Next thing that we're going to do is we're going to label our figure. So 60 inches is here, 72 is about here. So we are looking for this whole area right here. So all those women between 5 and 6 feet. Okay, so again, we're just going to go to the calculator. Okay, so we're going back to our second distribution, choosing that normal CDF. Our lower bound is the 60 inches. Our upper bound is that 72. Our mean is 65.5, and our standard deviation is 2.5. So there we go, 0.98. Okay, so the probability, or the proportion of women between 5 and 6 feet is about 0.98. So what is the proportion of women between 5 and 6 feet? About 0.98, or the other way, 98% of women are between 5 feet and 6 feet, or 60 inches and 72 inches. Okay, so I want to tell you on the homework, the expectation is 1, that you define the variable. So what I did in yellow above. You need to draw and label the figure. You need to shade what you're looking for. And you need probability notation. Which are these two pieces here. So I expect that from the homework. Now, if you can reuse your figure like I did right here, that's great. Reuse your figure, that's fine. If not though, if you're calculating 5 different things, you might need 2 or 3 figures so that you can accurately shade everything that you're looking for. Okay, now likewise. Well, first of all, we're gonna skip that one because hopefully you get the point. Likewise though, let's go in the reverse direction. We're not going to do all of them just in the interest of time. So we are going to do this middle 50% and the top 2%. So first thing, like I said, expectations above. Let's define the variable one more time. Women's heights are normally distributed with a mean of 65.5 and a standard deviation of 2.5. Don't get lazy. Write that for every new problem. And then we're not being lazy. We're drawing our figure. Okay, so we have a mean, standard deviation, 2, and 3. And then we have 1 lower, 2 lower, and 3 lower. Our mean is 65.5. If we add that 2.5, we get 68. 70.5, 73. Go down, we get 63, 60.5, and 58. Okay, so this time we're going in the reverse direction. The question is how tall a woman must be to be in the middle 50% and the top 2%. We are going to start with this top 2% one. Oops, wanted to change that. So we're going to start with top 2%. First thing that you're going to do is you're going to take a guess. This is the height that I'm looking for. What I know is that this area right here is 2%. Okay, because we are given an area, we will be using inverse norm. Now, this is the one to remember that our calculators work a little bit differently. My calculator does not ask for the tails, the left, center, right, or tails or area. I can't remember how your calculator does it. So you might have one that asks for your left, center, right, in which case you can just do that inverse norm where your area is 0.02 and you've chosen the right. I can't do that though. So remember, my calculator doesn't do right, it only does left. So instead of 0.02, I'm doing 0.98. So on my calculator, I will have to do inverse norm of 0.98. And then we're going to have to give the mean and the standard deviation. So let's take a look at the calculator. Okay, so on the calculator, we're going to go to second distribution and inverse norm. Our area is 0.98, mean of 65.5, and standard deviation of 2.5. So there we go. We get an answer of about 70.6 inches. Okay, now we need to ask ourselves if that makes sense. And we'll take a look back at the figure in a minute. But does it make sense that to be in the tallest 2% of women, you would be 70.6 inches? Well, yeah, that does. I want to show you on my calculator what answer we would get if I didn't put in that 0.98 and I just read right off the bat that 2%. So if I did inverse norm this time and I did 0.02 because I saw top 2% and 65.5 and 2.5, I would actually get an answer of 60 inches. Okay, so when we look back at our figure in a minute, we'll see that that does not make sense. Top 2% is not going to be 60 inches. Okay, so let's look back. We see right here, this is what we're looking for. We got an answer of around 70. Now remember, I just put this where I felt like might be appropriate, but 70 inches makes a lot more sense than 60 inches. 60 inches is not going to be the top 2%. Okay, so to be the tallest 2% of women, you're going to be about 70 point something inches, but I can't remember what the actual answer was. Okay, so now what if we do this one in the middle where we want to be the middle 50%? So middle 50%, I don't know where that is, so I'm just going to take a guess. And I have some height here, and I have some height here, such that I have 50% of the data in the middle. Now again, some of you can do this in your calculator. You can do inverse norm of 0.5 in the middle, and it's going to give you 2 values. If you're like me and your calculator won't do that, we're going to start with this side, which is 25%. So you would do inverse norm of 0.25, comma 65.5, comma 2.5. And if you did that, you would get about 63.8 inches. So that's this first one right here, which makes sense because it's below the mean. But we also have to find this height. So that one we have to figure out what is the data below it, because the calculator only does the data below it. And this time we're taking 75%, right? Because we have this 50% and this 25%. So if I did inverse norm this time of 0.75, I would get an answer of about 67.2 inches. So for a woman to be in the middle 50% of heights in terms of women, she would need to be between 63.8 and 67.2 inches. Okay, so now that we've gone through the 68, 95, 99.7 rule, and we've done the calculator, let's put it all together in an example. In a recent tennis tournament, Rafael Nadal averaged 115 miles per hour on his first serves. Assume that the distribution of his first serve speeds is approximately normal with a mean of 115 and a standard deviation of 6. Very first thing that should be happening, if you see that this is a normal distribution, is you should be making a figure. So let's start with that. Let's make ourselves a nice normal distribution that is well labeled so that we can use it, hopefully often, or for many of these parts. Okay, mean of 115 and a standard deviation of 6. So I have to add 6 every time to get up, and then I have to subtract 6. Okay, now let's look at the first part. A, about what proportion of his first serves would you expect to be slower than 103? So 103 is right here. So we want everything below it. So the first thing that I'm going to notice before I pick up my calculator is I'm looking at 2 standard deviations, which is 95%, about 95% of the data. That means that outside of 2 standard deviations is going to be about 5% of the data. That 5% though is this tail and this one. So 95% here, which means 5% outside. So this tail and this tail. So when we divide it in 2, we have about 2.5%. But look at what you're actually being asked for. You are being asked for what proportion? What proportion, not a percentage. So we would say about 0.025. Okay, about what proportion of his serves would you expect to exceed 120 miles per hour? 120 is not one of those nice numbers. 120 instead is about here. So this is one that we're going to have to go to the calculator for. Okay, like I said before, anytime you're using the calculator, the absolute most important piece that you write is the distribution. So we are going to say this is a normal distribution with a mean of 115 and a standard deviation of 6. This is so incredibly important. If you do not write that, you're not going to get credit. And you're like, well, it already says that in the problem. Yes, that's true, but College Board still makes you write it again. So we want to know now, what is the probability of being greater than 120? So at this point, we're just using a calculator. If you need a refresher, we're doing normal CDF. Lower bound is 120. Upper bound is 1 times 10 to the 99th. The mean is 115, and the standard deviation is 6. So if you do that, you get an answer of about 0.20. About 0.20. And that makes sense looking at our figure. That blue part looks like it's about 20%. Okay, C, what percent of the first serves are between 100 and 110? So looking on our figure, here is 100, here is 110. So this is the area that we are looking for. And again, like I said on the previous page, I always expect a figure. I expect that you have a figure and that you shaded it. We already said the distribution is normal, so that still applies. So now we're just looking for the probability of being between 100 and 110. And again, you're just doing normal CDF in the calculator. This time though, we're asked for a percent, not a proportion. So if you do this, I will tell you, you get an answer of about 19.6%. Okay, next up, the fastest 30% of first serves go at least what speed? The fastest 30%. So what we're looking for is something like this, where we have some number here, who knows what that number is, where this area is 30% or 0.3. This is where students sometimes get confused. Anytime, like this one, where you are given an area, you are going to use inverse norm instead. So you are going to use inverse norm because you have an area and you're looking for the number that goes along with that area. So inverse norm, you need the variable definition, which we did, and you need a figure, which we have. So that's great. Now that we have those two, you're going to do inverse norm. And then it depends on how your calculator works. Some of you can put in this upper 30% or this 30% on the right. Again, my calculator can't, so I'm going to have to do the lower 70% instead. And then mean of 115, standard deviation of 6. If you do that, you get the fastest 30% to be at least 118.1 miles per hour. Okay, one more. Let's take a look at E. A different player has a standard deviation of 8 miles per hour on his first serve, and 20% of his serves go less than 100 miles per hour. If the distribution of his serve speeds is approximately normal, what was his average first serve speed? Okay, so what was his average? So we're looking for mu. I would suggest that we start with a normal distribution. Okay, so we have the mean. We don't know what that mean is. And then we have 1 standard deviation, 2 above, so on and so forth. Okay, so standard deviation of 8, so we're adding 8, we've added 16, we subtract 8, we subtract 16. Okay, so then next thing that we know is we know that 20% go less than 100 miles an hour. So I don't know where that is. I'm just going to take a guess that I have 100 miles an hour here, and the area below that is 20% or 0.2. Okay, so at this point, we have to be thinking, what are our options? Well, on the calculator, we can do normal CDF, or we can use inverse norm. So which one would be appropriate? Well, normal CDF is used to find an area. Well, in this case, we already know the area. The area is that 20%. So normal CDF maybe is not appropriate. Inverse norm, on the other hand, we use when we have the area. That seems like it might be a little more appropriate because we have that area of 0.2. So normally in inverse norm, we would input our area, which is 0.2, our mean, and our standard deviation. Okay, well, we don't have a mean. So we can't put in 0.2, question mark, and a standard deviation of 8. We can't do that. We cannot input question mark for the standard deviation, for the mean rather, and then a standard deviation of 8. We're not going to be able to do that. And so instead, if we put in a mean of 0 and a standard deviation of 1, what we're going to get back is a z-score. Okay, so we're going to have to see, is that helpful? Well, if you do right now, inverse norm of 0.2, 0, 1 on your calculator, you would get a z-score of negative 0.842, about. I've rounded it. Okay, so first of all, does it make sense that we would have a negative z-score? Yes. It does, because we're looking at an area less than the mean. So a negative z-score does make sense. Okay, so then let's think back to our z-score formula. It's x subtract the mean over the standard deviation. So let's plug in what we know. We have negative 0.842. We're talking about 100 miles per hour. Subtract the mean, which we don't have, over a standard deviation of 8. Okay, so yeah, it looks like we can use this to find our mean, to find our average. So if you were to go through this calculation, you get a mean to be about 106.73 miles per hour. So this other player has an average speed on the first serve of about 106.73 miles per hour. Okay, this last question we are going to skip since we're doing this all by video. We're going to skip that last question. Last thing we are going to cover is assessing normality. We're not going to do this in this video. We'll wait until I come back and then we can go over it together. So before you leave though, this video has been a lot and it's a lot on the calculator and I've thrown a lot at you and it's hard with me not being there. Remember, I've put some resources on Schoology for us. The videos, if you need those, please help each other. Use this video as a resource. If you need to go back and rewatch things, please do that. If you have questions for me, write them down, arrange a time for us to meet. Normality is very important and it's the basis of everything that we do second semester. So if you need help, ask. I'm happy to help you. Okay, thanks for sticking with me and I'll see you next week.